So yeah, let me introduce and invite to our virtual studio our next speaker. It's Hunar Letsko. Gunnar, hello.
Hello, guys. Nice to meet you. Awesome conference. Honestly speaking, we on Wednesday, on the first day, we had in Georgia co-watching, and it was fantastic. It gathered different guys, and we were in Batumi, and even some people from we were in Tbilisi, but some people from Batumi came to us to see it.
Wow, wonderful. Great to hear that Javon helps people finally getting offline. That sounds
Yeah.
great. So, yeah, we don't have a lot of time, so let me ask you to share your screen and we'll dive right into your talk. I will just remind everyone that we have two chats on YouTube and on the platform, so please write your questions, write your reactions, your comments, what you think about the talks, your maybe additions to what speaker are talking about. We reading everything and we will try our best to ask you questions. Yeah, Gunnar, good luck. Let's go.
Yeah. Hello, dear colleagues, and welcome to Tech Talk dedicated to Micronaut. First of all, thank you for your making time to attend this presentation. Before we start, let's get acquainted. My name is Hunar. One more time, I almost 10 years in IT. I'm engineer and manager and participated in different projects on different roles, starting from junior developer to solution architect. As you already heard, I'm from Georgia, I'm from Tbilisi, and here I'm a part of our local Java community, Georgie. And I arrange a lot of tech talks, and I hope some of you already attend some of them. So before we start and go to our agenda, I hope some of you haven't heard about Micronaut, and for these people, I guarantee that at the end of this TikTok, you will have a basic understanding what is it Micronaut is, how to Micronaut to use, and what is the main difference between Micronaut and Spring Boot. And for these guys who already has an experience, I hope you find something interesting also. So what we're going to consider here, as I mentioned, we will work through some general concepts of Micronaut. Then I will dive into details how Micronaut creates bean application context. Then I will sum up this with the live prod example and compare it with the most famous competitor of Micronaut and Spring Boot, Quarkus. So let's move on. Let's go through the history of web application creation. And firstly, we start with per servlets. Then we have EGB. Then Spring came to us and save us, bring us this flexibility. After that, we have in Spring Boot that's bring us executable jar, uh, dependency consistency, and other useful features. And nowadays, we have different choices. We can choose Spring Boot, Quarkus, Micronaut, and there are dozen maybe other vendors framework that we can use instead of Spring Boot to build some web application. I hope everyone is aware about how Spring Boot works, because during the whole presentation, I will refer the key features to Spring Boot and compare it. So what Micronaut is, as I mentioned, Micronaut is a framework that provides the same capabilities that Spring Boot has. It also provides executable jar and so on and so forth. And you can build your web service based on this. Micronaut has two different type how you can build your run your application. You can use command line interface to start it, or you can use web interface. On this slide, you can see the main basic commands that you can use to build your application. Micronaut has been created in 2018, yes, by guys who created Grails. and they were inspired by Spring Boot, but they also want something to improve. And the main languages that Micronaut uses is Java, Groovy, Kotlin out of the box. But if you want to write your code in Scala, it's also possible, but with help of additional plugin. As I previously mentioned that Micronaut has been developed in 2018, this is a time of microservices, time of clouds, and Micronaut is designed to build microservices. So it out of the box support these microservice patterns like a retry mechanism, load balancing, discovery service, circuit breaker, and on the second side, it supports serverless functions. It supports Kubernetes, native images. So it builds to cloud and to microservices. If we're talking about microservice architecture, we always put in mind that we need to use some messaging system. And out of the box, it supports the most popular cloud agnostic messaging system like Apache Kafka, RabbitMQ, ActiveMQ. If we're talking about clouds, it also supports SQS, SNS, PubSub. It depends on which cloud are you using, so you can, without any problem, use messaging system. Another important aspect when you are working with microservice system is security. And out of the box, Micronaut supports built-in endpoint, working with GVT tokens, session authentication, security events, and so forth. For more details, you can look at this slide and see what you can really use out of the box. For other stuff, there are some libraries that you can use and customize it. When we're talking about management and monitoring, so Micronaut also provides some built-in endpoint that you can use like Actuator in Spring Boot, or you can customize this built-in endpoint. For example, health check, create your own health check and customize it in application YAML. And yes, you are right, you're correctly heard, application YAML. So there are no so many differences between Micronaut and Spring Boot, and configuration is also stored in application YAML file. Let's dive a little bit deeper. And the cornerstone of application context in Micronaut is also bean. Beans have different scopes, and on this table you can see the scope. Let's go one by one and consider. Some of them are absolutely the same like in Spring Boot, and some of them are absolutely different, and some of them are new. So singleton, absolutely the same, one bean, nothing special. Context scope is like the singleton, but it create at the same time as application context is created. So it is eager initialization. Other bean scopes, almost all are initialized lazily, and we will consider it a little bit lately on the our live. So infrastructure beans. Infrastructure beans are the beans that can be overridden. Micronaut provide this functionality to override beans. And for this, you can use annotation replace. But infrastructural bean can't be overridden and they will fail on startup time. Prototype. Prototype is absolutely the same like in Spring Boot. You can create as much instance as you need of this bean. Move on. Thread local. Thread local is, if you are familiar with thread local type in Java, you will understand the scope of this bean. it creates each bin for each thread. Refreshable is for me, it's most interesting one, and I want to stop here. Refreshable scope is a custom scope that can store some like caching data and be refreshed by refreshing point. But what I want to emphasize here that refreshing point is built-in endpoint that by default is disabled. And if you want to have this ability, you should customize this endpoint in your application YAML file. And request scope. Request scope is absolutely the same like in Spring Boot. So for each request, you create for your bin is created. Let's move on. One of the most interesting and useful thing in Spring Boot is starters and conditional bins. Micronaut also supports such kind of functionality and support the different and wide range of these conditions. But what is the difference? The difference is in annotation. So conditional bins, if you want to create conditional bins, you place annotation on your class level with requires annotation, and in parentheses put the condition. It can be presence or absence class and class path. It can be environment, or in Spring it names profile. It can be properties, environment variables, and so on and so forth. So a wide range of different conditions, and for more details you can go to the documentation and find all of them. And here we come to the differences, and these creators of Micronaut name it as advantages over Spring. The main point that application context, all bin definitions, and other helper stuff in Spring is created on runtime and with help of reflection. It consumes memory, and it slows down the startup time of your service. And that's where Micronaut creators find it inconvenient and try to improve it. So they move the creation of bin definition from runtime to compile time. And they strive to not just use reflection, but avoid of using reflection and use introspection instead of it, because that's how we can save memory consumption and decrease it, save our memory. Let's take a look at the code briefly. For example, this is our service. And let's go to the classes and see what is generated. For this publication service, we have bin definition that has been constructed. And we have bin definition reference that tell us what is the type of bin is created, what is the type of bin definition, some metadata, and what is this bin? Is it primary? Is it context? Is it conditional? Is it singleton? And so on and so forth. So this is the main advantage, but we will see a little bit more generated code a little bit later. Micronaut also supports different types of tests. So it supports Makita and JUnit test, and it has its own integration test framework, like Spring Boot integration tests, right? You can use an extension for JUnit 5, Spock, or Code test. It starts automatically service. You can replace your beans, mock them, and work with tests. For this project, also is written some tests, and let's take a look at this test. So first of all, if you want to write a test for your service, you should put annotation Micronaut test. Then, if we switch to our service, we have only one dependency. This is our repository and several methods. Here we have this dependency. We inject it and inject our service that we want to test. But we can not mock it, but we can mock it if we want to simulate some behavior. And to mock it, Micronaut also provide this annotation, mock bean, and you should implement some method and use mock static mock method of Makita. If we look at the test, there is no difference between Makita test or Micronaut test. So it is simple as it is. If, for example, we look at the controller tests, for example, we have controller. In controller, we have some method and service. And let's firstly look at the controller code. It's too easy. Put annotation controller. We have one dependency, injection with help of constructor, and one method. Here we inject this service. We inject HTTP client. This is Micronaut HTTP client. And also we are mocking the service, for example, and we make some request. We block it because HTTP client is written in reactive mode nature. And then we can get response status, response body, and validate it, and so on and so forth. So that's it if we're talking about tests. So, and in conclusion with test, let's run it and see that this is working. It will take for a while, I think. But as you can see, it is pretty straightforward, nothing special, and it is similar to Spring Boot tests. So yeah, my computer decided to make some surprises. Okay, I will left it and we'll come back to this and move on. So now live example. First of all, I want to start our journey from the build Gradle. How Micronaut generate this code. It's created by annotation processor, so nothing special. And you can see test is finished, successfully passed. So nothing special. Let's come back to our annotation processors. You can see many annotation processors. Why? Because Micronaut positioned themselves as a lightweight framework. So if you need something, you should enable it to have lightweight service. For example, let's go through one by one of this annotation processor. This annotation processor is for Swagger. This is for validation. This is for data GPA, like Spring Data GPA. Micronaut has its own implementation. This is for injection bean injection, and this is for HTTP validation. And we can customize our Micronaut application in this section. This tells us that Micronaut use Neti as a service. It use GUnit 5 for test and put some package for annotation scanning. We can customize to run it on Tomcat, but if we add a Tomcat, we need to add additional dependency to have a dispatcher, because by default it uses Neti under the hood. Let's come back to the controller layer. Controller is look pretty similar like in Spring Boot. So you just put controller annotation with URL mapping. And for each method, you will specify get, post, put, patch, delete, and so on and so forth. Let's go to bytecode to see what is generated for controllers. What code is generated for controller? For example, publication controller. Also bin definition, reference, and that's pretty it. If we want to have some more specific logic and we want to have some validation, for example, we have validation, custom validation. We mark this controller as validated, and this is Micronaut, also annotation, and put some custom validation for our model. And what I want to emphasize here that we must have this model introspected, marked with introspected annotation, because our validation will not work if we omit this. Micronaut should know about our model and can access their fields. If we look at the bytecode, you can see that this is introspection created for this bean, for this class, and reference to have ability to use it. If we look at the controller, for example, image controller, we have intercepted. So Micronaut create a proxy and use this proxy for this controller. So after controller, we are going to service. For example, publication service. As I previously mentioned, put just singleton or context and other bin scope annotation, and Micronaut will know that the bin should be created. But if we have some additional logic, and for example, we have some transactional methods, Micronaut will create also proxy, and let me share. Intercepted, and for this method with annotation transactions, it will create a proxy. So this is how we can see that how transactional our work is working. Pretty interesting. So if let's move on to repository level. Repository level is the same, absolutely the same like Spring Boot data GPA. We put repository annotation, and in repository I put the name of the data source. Why? Because for this service I have two data sources. As you can see here, name of the data source and some configuration. And the first must be default. This is a rule of Micronaut. And the name of the method, like in Spring Data GPA, find all order by name. So it's pretty clear. There is no difference. If we let's before move to the entity layer, I will show what Micronaut generates as for repository, also bin definition, and exact, that it show how it dispatch the action that comes to us, and bin definition reference with information of what bin should be created, right? And by default, repository annotation is also singleton. And entity layer. Entity layer, absolutely the same annotation, are the same JavaX annotation, so no difference. What I want to show you that all entities are introspected, and introspection for each entity is created with information about fields. Let's come to the bin validation. For bin validation, I created my custom annotation, and for custom annotation should be created some validators. And here is another way how to create a bin. This is a factory class. Factory class is absolutely the same analog of configuration class in Spring. So you can create, and here I deliberately create validators with help of this factory class to show this ability to have a different type of creations. And if we want to take a look at the code that generated, you can see that sort order validator 1, validator 2, reference, and bin definition is also created for this. Absolutely the same. Okay. One more thing that I want to mention is the configuration properties. Micronaut also supports like Spring Boot configuration properties, where you can put the prefix of your configuration. And in application YAML, it will analyze it and find that at this prefix we have these properties. And if we look at application YAML, we also can configure Micronaut, configure course, port, Swagger configuration, flyway integration, and so on and so forth. And if you take a look at the name, we have different environments, like you can specify as much as you want. And what I want to mention, the last but not least thing that is also important and interesting, is error handling. If you need to handle your exception, you need to implement exception handler, where first parameter is the type of the exception and the second one is the response type, and implement handle method. Here is important to put produce annotation. That annotation tell us that we produce some object outside. Without this annotation, it will not work. And as you can see, it is for each type you should create each implementation. That's pretty it. What I want to show you more is how does it work. So as I mentioned previously when we discussed bean scopes, that by default initialization of beans are lazy. So if we command this annotation and run the application, application will run safely without any problem. Let's see. Wait a minute, please. Something with my Windows. Yeah, it built the service and start the application. It will not take long, like 7 seconds or something like that. Oh, today, before this, it was 7 seconds, but okay, no problem. And if we make some request for this publication, we will see the error, 500 error, because our bean initialized lazily. But if we, for example, for publication service, change the bean scope to context, that tells us that it should be initialized eagerly, we will see it on the run of our application when we start. It will also take a while. Yeah, it's look like my computer want to a little bit joke about me. Before this talk it was fast, but okay, no problem. We will wait, we have a plenty time. Yeah, as you can see. And let's fix everything and see that this service is working. Mm, by the way, this is a real service that is working on production on my previous customer. That's why I'm not showing a lot of complex logic. And this is service is working 1 year without any bugs, and I'm happy that it is working. And it's worked fast. Mm, just my laptop decided to make some jokes in front of all of you. So let's fetch. Yeah, everything is working perfectly. Let's talk about drawbacks of Micronaut. As I mentioned, and it is obvious that if we move creation of bean initialization, some bean definition generation, and other helper stuff from runtime to compile time, we have longer compile time, right? And bigger size. Comparing to Quarkus and Spring Boot, Micronaut has small community. And as I show you, not convenient error handling. You can create implementation for each type of exception. Obviously, we can create a factory class like configuration and put everything here. Yes, it is, but for me, controller advice from Spring Boot is more convenient. And yeah, one thing more came to my mind, that Micronaut testing framework that create this integrational test, it built the whole application context and run the whole application. So if you have some integrations like with the database or Kafka or Redis, you should use some test containers. And according to documentation, and I haven't found any information that you can somehow disable some of the functionality. So this is also like a drawback. Uh, let's go to comparison with Quarkus. I deliberately not compare about performance and memory consumptions. Why? Because it depends on the service side. For example, bean validation in Micronaut uses introspection. In Quarkus, it uses reflection. And if uh, we are using Quarkus small services, it works faster and less memory consumption use. But when our service become bigger and bigger and have more and more logic inside it and validation logic, for example, this reflection will eat memory, and where Micronaut can win and will win for memory consumption 100%. And if compare other stuff, we can see that Micronaut a little bit older guy. And about supporting languages, in Quarkus we have Java, Scala, Kotlin. In Micronaut we have out-of-the-box Java, Groovy, Kotlin, but Scala is also possible, as I mentioned previously, that with help of additional plugins. In Bootstrap phases, I emphasize that Micronaut has compilation time, where it is generated this code, and runtime, where it gather all bin definition and construct bin tree. In Quarkus, we have a little bit different. We have augmentation phase, where code optimization, bytecode optimization, and so forth. And then we have static initialization and runtime initialization. Tests against native image. Why I deliberately put it here? Because in 2021, Micronaut doesn't have this ability, but Quarkus has. And now, thanks to this competition, Micronaut has this ability. Micronaut didn't have a web initializer, and now it has. So this competition bring us only advantages that we can consume as developers. You can find on the screen useful links that you can use. Documentation for Micronaut is great, really great. So you can find everything that you need. And I think this brings us to the end of the presentation. And that's it from my side. And I would be glad to answer to all your questions.
First of all, thank you very, very much for such a great presentation. I do feel that now we all know more about Micronaut and all will consider of bringing it to our project. So we do have questions and we do have a lot. So passing a voice to Alexander for asking them.
Yeah, so thank you very much, Roman, and thank you very much, Hunar, for your fantastic talk. I was really interested in, I'm keeping an eye on frameworks like Quarkus and Micronaut all the time, and we have definitely a number of questions. Let's start with the simplest one. So in Spring, we can use Lombok because it's super convenient. It's really easy to use it because, the code executed after it is compiled, and Lombok does a lot of code generation. But right now, in the Micronaut, we should somehow integrate code generation from Lombok and code generation from the Micronaut itself. So how smoothly does it work together?
Actually, what Lombok did, it used annotation processor to generate code, right? And after this code is generated, Spring use this code. There is an integration with Lombok and Micronaut, and there is no problems, so you can use it. On our project, we decided to not use Lombok because we also have generated code, and but there is this is not a tricky question, and
Mhm.
it works fine. So don't worry.
Okay, great. Thank you very much. Another question from our audience is also related to syntactic sugar and developers, let's say, performance. So another question is about smooth integration with Kotlin. You mentioned that Micronaut works smoothly with Kotlin. However, the question is, does it support, let's say, good features like null safety, like Spring does, especially in scenarios when we need to integrate code written in Java with code written in Kotlin?
Honestly, I haven't tried to write this service in Kotlin.
Mhm.
But I saw some examples of the service that is written in Kotlin, and it was working. I
Mhm.
don't think that it should be any problem because it two Java-related GVM languages, and guys who created Micronaut, I think they also consider it and kept it in mind.
Okay, great. Thank you very much for answering. Well, Spring Boot 3 wasn't released really recently, but it was released, let's say, this year. Well, not really far, not really a lot of time ago, and it brings a lot of fantastic features to us. For example, it allows us to build a declarative REST client and choose implementation, underlying implementation, almost on the fly. So the question from our audience is, which HTTP client does Micronaut use by default? Is it possible to switch it on the fly or during the configuration or somehow?
Micronaut by default uses reactive HTTP client, and it is working based on NATI, and you can write even your code in reactive mode. And
Mhm.
as it is not based on servlet, and if you need to run your application on Topcat, you should add additional dependency, Micronaut servlet dispatcher, something like that. And after that, it will adaptate its infrastructure to servlet dispatcher. But under the hood and natively it is reactive. And if we, for example, want to implement some server sent event, it is only can be implemented in reactive way in Micronaut. So a lot of stuff is done in Micronaut under the hood in reactive way.
Yeah, great, great. Thank you very much for answering. And in this case, I have another question also from our audience. So, because Micronaut does a lot of code generation, uh, it might be hard to debug it. What's your experience in debugging the Micronaut applications?
It generates only some stuff that is used to create application context. The
Mhm.
same stuff Spring Boot generates on runtime, and it is not easy to debug even in Spring Boot, but this is some internals, and if it is failed to start, it tells you where it failed to start. And as I previously showed, when I commented repository, we have this information error message that repository is absent. So well descriptive, and they created nice core, really nice core. Micronaut core is gives you detailed and clear error messages. uh,
Mhm.
I know that not such a big community, and Stack Overflow is not filled with all answers, but one more time, clear messages and documentation help you to handle a lot of stuff.
Yeah, thank you very much for answering. Well, a really similar question regarding developer experience. So in Spring Boot, I'm a big fan of Spring Boot dev tools because it significantly streamline and boost your developer experience. Do we have anything like that in the Micronaut?
Quite interesting question. You know
I
that
knew.
you know that in Quarkus has its own plugin that make your life easy. For example, if you have ultimate IntelliJ IDEA, yes, you can alleviate your life. It can alleviate your life, but for community edition, you should do a lot of stuff by yourself. Yes, this is a pain point, but only hardcore, only challenges.
Yeah, definitely, definitely. And I'm asked most of the question from the Sprint guy perspective because I've been using Sprint for long. I see a lot of applications are built on top of it. So that's another important question again for the person who may consider moving from Spring to Micronaut. In Spring we have a killer feature. It's a Spring Boot starter. You just add a dependency and it works out of the box. Do we have anything like that in Micronaut? And how hard is to write your own Micronaut starter? Let's call it like this.
uh, you know that to add new dependency, I showed annotation processor one by one, which annotation processor is looking for what annotation and build definition. If to add a new feature, it's not hard. You just add a new dependency, and if this dependency has something under the code, for example, if it is like killer feature like GPA or messaging or
Mhm.
Swagger, you should have this annotation processor. If you need to do something special, I think you need to create some annotation processor, or you should create deliberately bin definition. What
Okay.
I like in Micronaut, for example, how to and why we chose this on our project, because it takes me one day to rewrite my Micronaut application into Spring Boot application. Only just rewrite annotations, imports, and build Gradle, and the same for in the vice versa, so it works.
Mhm.
If we need some features to run our code, yes, we need to implement it, but Micronaut aspired to cover everything, and we need to wait some time. You know that Spring is pioneer, and all other guys will follow the Spring. It's 100%. Spring is pioneer, and should be accepted. But for lightweight service with not some custom logic, Micronaut is a great choice.
Okay, good. Thank you very much for answering. So the next question, again, I really want to know more about Micronaut. So you mentioned that in order to rewrite application from Micronaut to Spring, what you did, you just changed annotation and imports. And I'm quite curious, does Micronaut introduce its own annotation or use annotations from Jakarta, like singleton, like context, named bin, and so on?
Micronaut supports Jakarta annotation.
Mhm.
This and has its own annotation. So there are two ways how you can implement it, and no difficulties is here. So I think that's the answer, right? Or
Mhm.
may should cover something more.
Well, yeah, that's definitely an answer. And let's go ahead and talk about other modern features because Java develops and frameworks which run on top of Java also move forward. So that as far as I'm aware, Spring started to adopt virtual threads. and you can change deep inside into go deep into the inside the Spring and change one factory to another factory, and well, it works like a charm, and you will start using virtual threads. So what's the state of virtual threads in the Micronaut at the moment?
Yeah, I like this question. I'm also waiting this feature in Micronaut. I haven't checked the last version, but what is the last version? But I think soon we will have it, because as I compare Micronaut, Quarkus, in Spring they try to cover each feature that they don't have. For example, Spring Boot didn't have native images, but Micronaut and Quarkus had it, and Spring brought this native. And now Spring also support this feature, so they compete. And yes, in most cases Spring is pioneer, but it's not allow elapse a lot of time before after Spring that Micronaut and Quarkus will support the new feature. So
Okay. Yeah, I see it will definitely catch up rather sooner than later, especially keeping in mind so high level and highly competitive environment. Okay, moving forward, I still want to know more about the Quark Micronaut internals. I'm very sorry for asking so many questions. So see, in Spring, we have a fantastic capability which allows us to create beans programmatically. We can create a configuration class, put configuration annotation on top of it, and create bean. And what's more, we can put fantastic conditional annotations on top of them. Conditional property, conditional on environment, on cloud provider, and so on. Do we have something like that, like after magic configuration in Micronaut?
yes, for example, do you see my screen? Still see my screen?
I can see you, but we can ask our we can ask our colleagues to make your screen sharing visible.
Let me know if you can see.
It's visible
we can
now.
see now.
For example, look, this factory class is the same like configuration class into Spring. Here we put singleton. Singleton means the bean and with the scope. And here we can put requires annotation. And in this annotation, we can put any information that is depends. This is like, as I said, this is the synonym conditional beans. So it can require some environment, as you can see, property, conditions. You can write your condition, SDK configuration, default values, version, and so on and so forth, and being missing being. So as you can see, this flexibility is also supported by Micronaut. So, and even more, you can here write some Java code also in this method to make flexible bean creation. I think this cover this flexibility like Spring provide us.
Yeah, definitely. It looks like Micronaut looks like a next big thing which I should learn. Well, and I see that you've been to Micronaut for long, and also you're familiar with Spring. So if I ask you to compare Micronaut versus Spring, what is the main feature which is available in Spring but is not available in Micronaut, and vice versa? What feature do you miss the most?
What I really like in Spring Boot, controller advice, and I hate it in Micronaut. Their exception handling is horrible. I hope they will change it, but now we have what we have. About features, Micronaut copy all features of Spring. They don't say that Spring Boot is something bad, because they support absolutely integration with Spring. For example, we have Spring Cloud config, right? And Micronaut can work with Spring Cloud config, with Spring Cloud bus, these all events of modernization of your configs. They also can respond and react on this. So they can be built in the Spring Cloud ecosystem, and fits fluently in this ecosystem and feels great. They just try to adopt it, and what they position themselves that they do AOT generation of the code, and use introspection instead of reflection. That's what is the main difference, if simply put, between Micronaut and Spring Boot.
Awesome. Thank you very much for explaining it in such good level of details. I'm really satisfied with all the answers you gave us. Thank you very much.
Yeah, and the last question from my side before we say thank you, final thank you. A bit provocative question. Yeah, from day one, I do that. So for your next project, which framework will you use?
It depends on the size of the service and of the how many custom logic my service will contain. If it will use some standard frameworks without customization, I will definitely use Micronaut. But if I will have the latest version of Spring Boot and have some customization, I will use this latest Spring Boot with supports of virtual threads, and I also will feel myself comfortable, because I love Spring Boot. I really love Spring Boot, and I love Micronaut, so I love them both.
Yeah, that's beautiful ending. I would say that these are tools, guys. So each tools has its own benefits. So just consider it as a tools. So thank you, Gunnar, very much. Great talk. Thanks a lot for being here
Yeah.
with us.
Thank you, guys. Have a nice evening, and have a nice talk. So you have two more speakers with great and absolutely perfect topics.
Great. Thank you very much. Have a good evening. Bye.
Thank you. Bye.